Clocks, cars, bicycles, factories. Almost every machine that moves uses one of the oldest, most elegant inventions in engineering history, the gear. In the next few minutes, you're going to understand exactly how gears work, what they do, and why they're everywhere. At its simplest, a gear is a wheel with teeth. When two gears mesh together, those teeth lock, and the rotation of one shaft directly drives the other. That's it, simple concept, but the implications are enormous. The most basic job of a gear is to move rotation from one place to another. Think of a car engine. The crankshaft spins, and through a set of gears, that rotation reaches the camshaft, the wheels, the alternator. Gears are the messengers of motion inside a machine. Here's where it gets interesting. Gears don't just pass on speed, they can change it. When a small gear drives a larger one, the output slows down. When a large gear drives a smaller one, the output speeds up. This is called the gear ratio, and engineers use it to tune machines for exactly the performance they need. And when speed goes down, something else goes up: torque. Torque is rotational force. By using a larger output gear, you trade speed for power. This is why low gear in a car gives you more pulling force when climbing a hill. You're not going fast, but you're pushing hard. Gears can also redirect motion entirely. Using bevel gears, cone-shaped gears arranged at an angle, rotation on one axis is converted to rotation on a completely different axis. The car differential is a perfect example. Engine power comes in horizontally. Bevel gears turn that force 90 degrees to drive the wheels. There are 4 fundamental gear types. Each is built for a different job. Put it all together and you get mechanical advantage, the ability to do more work with less effort. Gears sit inside cranes, lifts, and heavy machinery precisely because they multiply force. A tiny motor can lift a ton when the right gear arrangement amplifies its torque. From the watch on your wrist to the turbine generating your electricity, gears are working quietly, tirelessly, transferring motion, multiplying force, changing direction. Now you understand exactly how. If this clicked for you, hit subscribe for more engineering explained simply, and drop your questions in the comments below.